Hi everyone, this is Nishok from SNS College of Technology. Here we are going to see the topic named MOS Non Ideal IV Characteristics from the VLSI design subject. So here we are going to see the transistor IV characteristics review and non-ideal transistor behavior and the effects due to non-ideal behavior and the assessment, and finally we are going to summarize the topics. So here we are starting with ideal transistor IV characteristics. So in the previous video we have seen about the first order transistor model, that is nothing but the ideal transistor IV characteristics. So under the three different regions, that is cutoff region, linear region and saturation region, based on the voltage, how how about the changes in the IDS that we have seen. So those equations are given here based on the three different regions. So here, coming on our discussion, non-idealities in MOS IV characteristics refers to deviation from ideal behavior in MOS transistor that impacts the performance and design considerations. So coming here for the discussion on ideal versus non-ideal characteristics. So while deriving the IV characteristics, we are considering the transistor is under ideal condition. So in ideal condition, we are having several assumptions. That is, we are assuming constant mobility. The mobility of N-type material or P-type material is kept constant throughout all the regions, and the threshold regions also, threshold voltage of transistors also kept constant, and no leakage current when the transistor is off. Linear increase of current with increased gate voltage until saturation. So this comes under the ideal IV characteristics. So here when coming to non-ideal IV characteristics, so that is as like we are seeing the transistor working in the practical condition. So that is the temperature, in a simple manner, if you want to say, the temperature variations or any manufacturing process variation or any connection variation, due to those effects the characteristics of the MOS transistor may vary. So the points that discussed here represents the non-ideal characteristics that starts with mobility degradation due to high electrical fields and threshold voltage variation and presence of leakage current even when the transistor is off, and channel length modulation and subthreshold conduction are some features of non-ideal characteristics that we are going to see one by one. We are starting with threshold voltage variation. So threshold voltage is represented as V subscript of TH, VTH, that is named as threshold voltage, the minimum gate to source voltage required to create a conductive channel between the source and drain terminals in a MOSFET, that is called as threshold voltage. Factors causing variation: body effect, temperature and process variations. The voltage difference between the body and source alters the threshold voltage. So similarly, temperature, changes in temperature can affect carrier mobility, ionized impurity concentration and influencing the threshold voltage. And similarly, the manufacturing process variations also will influence the threshold voltage. Similarly, the next feature is nothing but mobility degradation, which is otherwise named as a surface scattering. So here electrical field, high electrical fields in the channel can scatter carriers, reducing their mobility. So in the ideal characteristics we have seen the assumption that mobility is constant, but if there is high electrical field, if you see the image here, the between the two n-type material inside the channel, we have assumed that the charges are moving in a straight line, but here due to high electrical field the charges start to scatter from a straight line and start moving in a scattered manner as shown in the figure. So because of that the mobility will starts to vary, it won't be constant. So that is now named as a mobility degradation. Next, channel length modulation. As VDS increases, the depletion region increase and channel length become shorter. The current through the channel IDS is inversely proportional to the length of the channel. With the decrease in the channel, the current increases. So here if you see in the ideal characteristics, we have discussed that in the saturation region the current will remain constant even when the voltage increases, but that is given here in the picture long channel NMOS. But due to this channel length modulation, here we have seen short channel NMOS, the current starts to increase along with the change in the voltage even in the saturation region, that is shown in the short channel NMOS. Next, coming to the subthreshold conduction. So it is otherwise named as leakage current or else weak inversion or subthreshold drain current. So likewise we can say this topic under different names. So that is mainly based on the leakage current. So the current that flows between the drain and source of a MOSFET when the gate voltage is below the threshold voltage. By operating in the subthreshold region, the circuit can achieve ultra low power operation. So here we are considering in this subthreshold conduction is otherwise called as a cutoff region. So the current we have seen in the ideal condition, current in the cutoff region is 0. IDS is always will be 0. But here we are mentioning that there will be some leakage current. There will be some leakage current. So because of that leakage current, there will be some current flow. So those current flow is differing from the ideal characteristics of the MOS transistor. So because of this, such applications, it can be used widely in power efficient applications like IoT devices, medical implants and energy harvesting sensors. And next topic is velocity saturation. It is a phenomenon in MOSFET where the velocity reaches a maximum limit, that is saturation limit at high electrical fields, beyond which it is no longer increases linearly with electrical field. So performance constraints affects the overall speed and efficiency of the device. So here also we are discussing that the linearity ends in the saturation region, but here it shows the difference. So before the saturation region itself, the current comes to constant range. So that is called as a velocity saturation. So this also based on the electrical field, high electrical field, this issue comes. So we have discussed the comparison between the ideal characteristics and non-ideal characteristics of the MOSFET, and what are the factors that affects the ideal behavior of the MOSFET and how it affects the flow of the current inside the MOSFET. So the mainly channel length modulation and subthreshold conduction and mobility degradation, threshold voltage variation. So these are the topics that we have discussed here, which affects the IV characteristics of the MOSFET. That comes under the topic non-ideal MOSFET characteristics. So here this is time for assessment. So what is the cause of channel length modulation, and list the other names of subthreshold conduction, and list the factors influence MOSFET to non-ideal effect. So that's all about non-ideal characteristics. We can see in our next video. Thank you.